Alright, so let's learn how to make our game stand out using the camera and various visual effects. You've learned so much already. Let's go one step further and add in some visual effects. In this course, you'll learn how to work Phaser's camera to create some simple but stunning visuals. Phaser also offers camera effects like a camera shake and fade out. Once you grasp how you use these concepts, your games will start to pop. Sweet. Alright, let's begin. This is also the last module in the course, so we are in the home stretch here. Cameras, really. You can code cameras in here. Whoa, there's Cody. He's running. Can he jump? Cannot jump. He's back in his snowy environment. I'm gonna fight some evil snowmen here. He's breathing very quickly. He's gonna hyperventilate. Alright, in order to grant the joy of exploration and discovery, it becomes important for the game world to be larger than what a player immediately sees upon entering the game. A useful way to convince the player of your game of this is by employing the use of cameras. A camera is a view of the game world. Some games, those with minimaps for instance, employ multiple cameras, but we'll be focusing on just one. Phaser creates a camera by default, which we have so far been using without any customization. Its bounds are set to be the same as the dimensions for your game given in the config object. It also does not move at all, but we'll be changing both of those things for our platformer. Alright, so we are going to begin work on an honest-to-goodness side-scroller. Sweet. Platformer. Alright, create GameState.player, add the sprite, and then you set the camera bounds. Okay. And then you start a follow on the GameState.player. It's that simple. Look at that. You just start a follow on the GameState.player. Okay. Above, we modified the default camera, this.cameras.main, to make it aware that the world is larger than our current window. We do this by calling set bounds and giving bounds larger than our config width and height. Yeah, okay, so we saw that. We've seen that method once before. Sort of. We saw a different method that included the bounds in it, right? So like the set world bounds so that your characters don't go off screen. In fact, we can probably see that. Yeah, so they set it for Cody here, the set collide world bounds to be true. And that way, when you use Cody, he won't run off screen. You can go all the way to the end here, and since the camera's not moving, not changing the world bounds, Cody doesn't move either. He is stuck in this box that we have defined for him. Okay, so after we set the bounds, we also tell the camera to follow along our main player by calling start follow and passing in the sprite we want to follow. That method also has several additional optional arguments that you can pass in, which we can use to customize how fast the camera locks onto its target and whether the target should be in the center of the screen exactly or offset somewhat. Sweet! Here are the arguments for start follow. Target, round pixels, lerp x, lerp y, offset x, offset y. I think this is like short for linear interpolation, but I don't know. Target is the sprite for the camera to follow. Round pixels is a boolean that affects rendering. Set it to true if you're experiencing camera jitter. Lerp and lerp y are the speed between 0 and 1, where it defaults to 1, with which the camera locks on the target. A lower lerp speed will have the effect that your character is moving much faster than the camera. That's interesting. I'm thinking of like Super Mario games where you get the invincibility star and then you're running across the screen. You end up going faster than apparently what this is called, the lerps of the camera, right? Or no, was it that one? Yeah, that one. So that the camera seems to like lag behind and your character is going faster than it. And then once in Super Mario, once the effect wears off, then you're back to the same camera speed. I guess the camera speed doesn't really change, it's just the character speed is changing. Okay, offset X and offset Y is the offset for the camera. Set offset X to something like -200. That will keep Cody on the left side of the screen so that more of the level is ahead on the screen. So that's basically the point where the camera starts moving. That's cool. Yeah. I think that's how we can interpret that. And then if it crosses that threshold, then the lerp comes in and says this is how fast it responds, how fast the camera reacts to the character crossing the offset threshold. Okay, cool. This is exciting, yeah. Much much more fun than programming little dots and circles. Okay, we've created a snowy background for Cody to run through. Let's set up the camera to run through it with them. Inside Level's create function, after the call to create animations, start by setting the bounds of the camera by calling this.cameras.main.setBounds with the following arguments. Alright, so let's look over our game file. We did not do that at the beginning. Just familiarize ourselves with it a little bit. And also check, so there's only the HTML and then the game file. So we'll just go ahead and look at that. They don't have a separate scene for the game start screen or end scene. So they've preloaded all of our images that we'll be putting in. They set the game state active to true, added the snowy background, added Cody. They added the platforms as a group. And then we have our create animation. So we'll go ahead and set up our cameras here. But before we do that, we're just going to quickly scan the rest of this. They set the world bounds for Cody. Set collide world bounds. And then they added a collider between him and the platforms. And they allowed the cursor inputs to control the character or to be set up initially. And then they set up all of his run animations, his idle animation. Let's slow this down so he's not like hyperventilating. Let's do 5 frames a second for that. And it's going to say that we're wrong because we didn't set that up. I was just trying to make him not hyperventilate. There, he looks a little more normal breathing. Okay, then we have his jump animation and his fire animation. And then lastly, in the update method, they have all the listeners for whether the right arrow is pressed or the left arrow is pressed. And then they also gave an else statement to set his velocity back to 0 if nothing is pressed. And as we saw the one other time we were animating him, they gave him an idle animation for that. And for the other two, they gave him the run animation. All right, so that's our current functionality. Of course, they have all the config file or the config object properties set up, setting it at a target frame rate of 60 frames per second, and then just naming the scene level. And as you can see, they use this level as the subclass instead of like game scene, which is what we've been seeing most often. All right, without further ado, let's set up our camera. So in here, we want to set the bounds of the camera after the call of create animation. So this dot camera, cameras, plural, dot main dot set bounds. And within this, it has 4 arguments. So 0, 0, game state.width, width, and game state.height. And I'll go ahead and add some spaces in here to make it look a little better. Game state.height. Like so. Okay. So we've set the camera bounds. I don't know. So the create animations start, like this create animations, I guess that adds in, because we haven't seen that before, I guess that adds in a cameras property to the game state object. Is that what we're referring to when we say this? Or is it scene? I think it's adding it to the scene, eh? So if we scroll all the way down, I want to know what this is referencing. Yeah, we don't have a reference built in there, so it must be like once you call the create animations method, it sets up the group of cameras for you to use, because I don't see like any camera group listed. That's my guess. All right, step 2. Now set the boundaries of the world to be the same as the boundaries of the camera by calling this physics world setBounds with the same arguments. Okay, so we're going to copy this line And underneath this, we're going to say physics. This.physics.world .set bounds, and then with the same arguments. Okay. And now follow Cody around by calling this.cameras.main.startFollow with 4 arguments. All right, this.cameras .main, or sorry, is that right? Yeah, main.startFollow. And this will have GameState.player. This is the sprite that we want it to follow. We want the, what was it called? It was the round pixels. Yeah, so this is the round pixels set to true so that there won't be camera jitter when it's moving. Round those pixels. And then 0.5 for the lerp. So it's like, don't lock on, but follow him fairly quickly. And then 0.5 for the offset. So it's sort of the same, but in the Y direction. Let's see. Here's the dot player. Oh, I see. Okay, so we're setting the lerp, but we're not setting the offset. So the camera will follow Cody, but at a relatively average pace. All right, let's go ahead and run this. See how it works. See how, whoa, he falls to the screen. Wait. Second argument is true. What did I mess up there? Oh, round pixels. I just literally wrote the word round pixels. You just have to set the round pixels to true. There we are. And now let's see. So we're not going backwards at all, but let's see if Cody can move forwards. Whoa, look at that. Look at that. Our screen is moving. We're running. We're seeing all the snow. Can we go back? We can go back, guys. Look at that. We can go back. Dude. Yes. So it's setting, yeah, the background. How is it doing that? So it's setting it like the width and height as the background image versus like the canvas size, right? That's cool. It doesn't look like they have anything looping yet, but I guess we'll probably find out how to do that in a little while. But that's cool, man. Look at that. It looks like they've like maybe like doubled it and then flipped it. Just done a mirrored image of the other background over here. And then there's a good loop point right there where sort of that hill rises up, and then you'll have a slope coming down for the loop point. Cool. Now we can actually wander around our world. We're not confined to this box anymore. Platforms. If we want to create a side-scrolling platform, whoa, Cody was there for a second. There he goes. Whoa. Okay. We better make some platforms for the player to jump on. We've created a static group for our platforms as before, but how do we decide where to place these platforms? This is a design choice, but we can at least make the design easier to accomplish by passing out X and Y coordinates and placing our platforms on a grid. Creating a system for our levels is important. We'll be able to create multiple levels using this tool, and this will allow us to separate out the code, creating the levels from the code that places all of the platforms. So we've created the function called createPlatform. Let's go ahead and see if we can find that. So they also added a level setup method, which we're not sure what that does. But as you can see, they have the follow, they have the world bounds, collide world bounds set to true. However, he is falling through the floor, so I'm not sure what's going on with that. We need to create platforms so he doesn't fall, right? It's interesting though, because I thought the world bounds were like, okay, he's gonna fall, but he's gonna hit the bottom and then stay there, unless they like later they said to eliminate the bottom barrier. Okay, so then they added the collider for us for the platforms in the player, so we don't have to add that in. We're looking for the create platforms method right here. Okay, create platforms function that takes an X index and a Y index to create our platforms. So if y index equals a number, and if x index equals a number, then we create a platform at a certain origin with the refresh body method. The refresh body method, not sure what that does. Let's see. So locate the level setup method and add in a call to this dot create platforms within the for loop to add platforms to our game. Use the x index and y index variables created by looping over this heights as arguments. Okay, so there's a lot of jargon there. Let me see if I can decipher that. So we want to go up to this level setup within the for loop to add platforms to our game. Is this referenced somewhere else? It is, yeah. So level setup, locate the level setup method. This method is being called underneath our animation setup, but now we're going to set our platforms in our level. So within the for loop, we need to call create platform here with an x and y index. So this dot create platform. This dot create platform created by looping over this dot heights as arguments. Within the for loop to add platforms to our game, use the x index and y index variables that are from here, and they are created by looping over. Okay, so this dot heights is not what we have to add. They already added that in. Dot entries is another method we haven't seen yet. I wish they were explaining these things too, but okay, we'll just put in our x index and y index. Okay, let's see what happens when we do that. Woohoo, there we go, we got Cody. He's running on platforms. The camera's moving, look at that. Can he jump? He can jump. He can even jump. They put that in too. We did this last time, but they're just adding it as we go. So this is like the space cursors, right? Cursors.space, and seeing if it is touching down, so just barely touching, so he's not jumping infinitely. And yeah, if we just set it to be like this conditional, where it's seeing if the arrows are held down, then if you hold down the space, you just keep flying. You just fly upwards, right? Infinitely jumping. But this way, he's just jumping, and you can't jump again. Let's see if there's any platforms this way. Jump, Cody! No. Do-do-do-do-do-do-do-do-do. Levels. And now that we have a system for specifying where platforms should be in each level, we can create multiple levels. Each level is going to inherit from our customized level class and then inject information about the level inside of the constructor. By doing this, we are able to separate each of our levels from one another. Also, what I can see with this is that you can randomize the platforms, right, to a certain degree. Once you add in other elements, it would get more complex, but you can randomize the platforms to a certain degree, and then add in your enemies based off of those locations. Or if it's like literally just the platforms and you want to make a game that just has a bunch of platforms with no enemies and you're just jumping, then you could do it that way, where you just randomize locations for each level, and then you could have infinite levels, right? Below the definition for level, create a new level 1 class that inherits from level. Okay, so this is a third layer of the classes, right? So the parent class that we're working with is phaser.scene. It's the whole construction of the game, all the framework for phaser. Our subclass is level. And now we are going to create a level 1 class. It says below the definition for level. I'm not sure why they say it like that, but it's basically outside of literally all of this. So all the way down here, we're going to create a level 1 class. This would be a good opportunity to create a new file in here, but they're not instructing us to do that. We're just going to stick with the one file for multiple levels. So if we remember this class, level 1, this is going to extend the phaser class, phaser.scene class. Okay, and that should inherit from level with its constructor. I don't think we need the constructor yet. We just need that. But I think I messed up with that's level 1, class level 1. Oh, inherits from level, not phaser C. This is going to extend level. Yeah, literally what I just explained. It's the third layer, right? Level 1 extends level. Give level 1 a constructor method that calls super, and then defines this .heights as an array. So constructor this will have a super, and then it says that super is going to have an array of this .heights. So that would, did you define a constructor method for level 1? I did indeed. Constructor super this heights. Oh, call super level 1 and then defines an array. Okay, so the super needs to be from level 1. That just needs to pipe it in as the string of it. So level 1, and then this .heights is going to equal an empty array. There we go. Okay. And lastly, change the property for scene. I knew that was coming because we have to add it in here. So level, and then level 1 is going to add in there, so the scene knows to look for that string when it appears. Oh, they just want it. They want it to point to level 1 entirely. They don't want the first level. But now Cody's just falling. Cody is just falling. Okay, I guess that's what they wanted to see happen because we haven't populated the platforms. We've not created those. Okay, that was weird. All right, shaking the they didn't really explain what that was for either, except to just create, like, here, you created a new level, but we deleted the first one, so I don't know. That's weird. I don't know, you got all that. What is all this? Tell us what this is. Okay. Camera shake is an indispensable effect in the modern video game. It hints to the player that something jarring and surprising is happening. When a player falls down, we're going to start the level over again, but shake the camera a little bit, as if to say, let's try that a little differently next time. Camera shake is an easy effect to add in Phaser. Just call the shake method on the camera, and the shake has certain arguments: its duration, intensity, force, which is whether or not to start the effect from the beginning, if it has already started. That's interesting. So the duration is the length of the shake, intensity is how strong it shakes, and then force is whether or not to start the effect from the beginning, if it has already started. So if you if there's a monster that's like throwing a hammer down on the ground and it's smashing up the ground, right? If he does that multiple times and the camera shake event is happening, is already started, it's in progress. The force, I guess, is a Boolean to say whether that shake continues until it completes, or if it restarts and then the shake happens again whenever that hammer hits the ground. The callback property is the function to call each frame while the shake is happening. Okay, it accepts two arguments, a reference to the camera and then a duration from 0 to 1. Context is the context of the previous function, defaults to the scene. Okay. So then this is the command that will shake the main camera fairly vigorously for 100 milliseconds. So that's because the duration is first, so that's 100 milliseconds, and it will shake it at 80%. Whereas this one will lightly shake the camera, so we've got 30% for 200 milliseconds. Halfway through the shake's completion, it will turn the GameState.player red. So the true here is the force, right? So it will restart if it has already started. And then the function here is the callback that accepts the arguments of the reference to whatever camera you're using, and then a duration from 0 to 1, which is set to whatever progress is, right? So that argument is then, that's going to be a duration from 0 to 1 in milliseconds, so 0 to 1000. If you want to think of it that way, you can just think of it as from 0 to 1 in seconds. And then they have a conditional with progress as the parameter that they're using. If it's greater than 0.5, then the player's tint will set to red. So apparently halfway through is indicated by the 0.5. So then progress is, a duration from 0 to 1. So this is an internal duration of the effect itself. So that is saying basically like halfway through the effect, right? 0.5. That's important to know here. They didn't say that, but that's important to know. It's an internal duration for the effect itself. That's what that duration is for. So you can set that to be 0.1, so 10% through, then start your animation. All right. So let's jump in here. So we've added a little more space to the world in the set bounds in order to make it so that there is one Cody length between the world we see that the camera won't pan to, or sorry, beneath the world that we see that the camera won't pan to. We want to make this our death plane. If the player falls down there, it means they've lost. Let's check if the player has fallen down inside the update method of our generic level layout. So inside the update, create an if statement that checks if GameState.PlayerY is greater than GameState.height. And remember, y increments downward. So 0 is at the top, and then the maximum is at the bottom. So if it's greater than the GameState.height, which is just the bounds of the screen, then we will restart the level, and Cody will lose a life. Let's take a look at this physics.set world bounds. Wherever this is, let's copy that and then bring up this here. No results for that, but we'll go ahead and take a look. Level key. Just looking at what the level key might be. Anyway, I digress. Let's find the set world bounds for the physics world. This physics world set bounds game state width and then game state height plus game state.player.height. That's cool. That's a neat way to do it. So basically, instead of trying to map out like how many pixels you need to make him disappear, just reference the character. Just reference him, and then it will say like however many pixels your character is, it'll add that to the game state.height for the bounds. So, and then he is contained within those bounds, but not the bounds of just the box that we see for the background of the screen, or what the camera sees essentially. In all of this, we can imagine that we are a camera looking into the world. There's more to the world than what we can see, but we're seeing a snapshot of that, so we are the camera. But the actual world, the bounds of that are increased by the height of our character plus what the camera can see. All right, so inside of the update, we're going to create an if statement that checks if the player's y coordinate is greater than the game state.height. In our update function, we see all of our listeners for the keyboard inputs. Underneath this, we're going to check the player height. GameState.player.y is greater than height. GameState.height. All right, now if we want to ever so slightly scold the player for a game for losing. So within our if statement, shake the camera to show your disappointment. Call this .cameras.main.shake with the following arguments. All right, so within this, if he does, and what happens is he does reach the bottom here, right? Right now nothing happens, and he's literally just underneath this, right? Let me see if he can jump. He can jump, but once he falls down, he cannot jump anymore. Interesting. That's very interesting. I wonder how they coded that there. We'll take a look at that in a second. Because really nothing is happening to the character, right? He's just touching the world bounds. There's no collider for that, right? If there were, we would be adding our logic here to a collider. Yeah, there's only one collider between the platforms and the player. That's interesting. Create animations. Oh, I see. So that's what the create animations function is doing. Yeah, so they just set up all their animations within a function and then called it in the create method up here. That makes sense. I don't know about that other question though. Heights.entries, update. They've got the runs, they've got the jumps. So if phaser input, if you're touching down the spacebar, then you play the animation of jump. And if you're not touching it down, wait a second. So if you jump, if the game state player body is not touching down, oh, okay. But why would they set that to true as well? I'm trying to solve like what made it so that when Cody falls, he's literally just right here. He's not falling through the infinite void beyond the camera frame. He's just right there. But yet you can't jump. So, and you should be able to keep going too. You can keep going along the screen even though he's like hidden underneath. Weird. I don't know. I don't see anything that's controlling whether he can jump or not, except for this. But all this is saying, if the body is not touching down, the animation of jumping is true, which just says that if he's not touching a platform, you'll keep it going. You'll keep that animation going to where it doesn't. He's just stuck in that frame until he touches down again, and then you'll switch back to the idle animation. Which again, I'm gonna set his breathing to more like normal, like not rapid hyperventilating. Set to like 4. There we go. Yes, yes. Okay. Anyway, let's add in our camera shake. So this .cameras.main.shake with the following arguments. We add this here in our if statement. This .cameras .main.shake. 240 is the duration of the shake. 0.01. It's a very subtle shake, very subtle scolding that you fell, or penalty. False. This is important because it will continuously start to shake and we won't see anything at all. Yeah, so it'll just infinitely loop because he's constantly in that same place. So we want that to be false so that it doesn't loop. The force, what they call force, is just if you want an animation or a shake to restart. But yeah, so then function, and then camera, and progress, and that'll be our callback, and then we'll add it in a second here. Okay. So lastly, we want to restart the level after the shake is completed. So right now, if we go down, if we drop down here, yeah, look at that. There we go. The camera is shaking. We can still move the screen because Cody's right here. But yeah, so the shake happens. That doesn't look very subtle. What is literally 1? What's 1? What is a shake of 1? Let's see that. Whoa! Can we still move him? Yeah. Okay, so that's the shake of 1. Don't know when we would ever want that, but that's like the maximum. Okay. Lastly, we want to restart the level after the shake is completed, so let's use our callback for that. Pass in the logic, when progress is greater than 9, then restart the level. Okay. So, if progress, which is that, it's that duration of the event, if progress is greater than 0.9, if the shake is 90% complete, which means like basically 90% of 240, so 218, then you call this dot scene dot restart. And then just have this dot level key so that it restarts that specific level and doesn't take you all the way back to the beginning. Because if you restart the scene, then it'll just take you back to level 1. So that's like a game over if you died completely. But this is just saying you just died once, you still have lives left, so we're going to restart the level for you. There we go. Now, if we go down here, the shake will do that, and then he'll restart. And he'll restart. Now, if we also, I'm curious. Let's negate this, right? If progress equals, or just like, if not progress, just say like this is definitely going to be false. Change this to true. I want to see what happens with if you change the force to true. Okay, so you can still move, but the camera actually doesn't shake. Weird. But if you set it to false, and it shakes and it continues to shake, and it does loop. Oh, I see. So it's saying that it's looping. When you set it to false, it will continually start to shake, but we don't see anything because it's always on the first frame of that happening. Gotcha. Okay, so let's set this back to what we had it. 0.9. I also want to see like or can we do like 2? We do 2? Does that work? It says it was 0 to 1. So I don't think that will ever, this has to be, it's never going to be greater than 1. So yeah, 0.9. And then if you want it to loop more than that, you need to set like the delay here higher to make it last for like a second. And then this would take 900 milliseconds to complete because that's 90% of the second there. Sweet. So yeah, and then we're going along. We're gonna play our platformer. Wahoo! Wahoo! See how far this goes. Yep, goes all the way there. I'm gonna go backwards. It's kind of fun to play around now. I don't know if we can make that jump. Let's see. Oh, see if I can jump like right here. There we go. Wahoo! Okay, cool. So we've got camera shake, we got level restart. Fading out. Fading out of the scene seems like a fitting transition. A cue taken from the film industry, fade out offers a much softer effect than the shake, but is as concise in phaser. So the dot fade is a camera method that takes the following arguments. Duration, which is the length of the fade in milliseconds. Red, which is the value of how red the color is, green and blue. Force starts the fade out over if it's already been started. Callback is the function used during the effect. And then context is the context of the callback function that defaults to the scene the camera is in. All right, when we call this, so these are all of our RGB values. They're set at maximum 255, which I think is white, right? If you do the RGB of 255 for everything. In the above code, the camera fades to white very quickly, halfway through the fade out. The GameState.player gets moved 5 pixels from the left edge of the game. So, whatever is happening here, over the transition happens for 100 milliseconds, for a tenth of a second. the force or the loop of it is set to false so that it will actually complete once. And then the function is similar to what we saw before with the camera in progress. Progress again is just that delay. Well, not the delay, it's the duration. It's how much progress the transition is made, how far along into the transition you are. So this is saying halfway through, then push the player to the right by 5 pixels. Okay, so in order to transition from one level to another, we need something to indicate the end of the level. In Code 4, Tundra Terror, we're going to use a video game staple, the bonfire. What we need to do is add a new sprite of bonfire to our physics engine. Then Cody, when he interacts with the bonfire, we fade out the level and put Cody in the new one. With the level setup we've created our bonfire and started writing an overlap function for it. Let's implement what happens when we get to the bonfire. Okay, so we need to find, let's go ahead and find our level setup. Where they've got that, that's here. And we need to find a this physics.overlap. See the colliders there. And we've got our animations. We've got a platform. We got an add sprite, and here's the overlap. This is in our level setup function here. Okay. So within this, fade the camera to black by calling this cameras.main fade. This.cameras.main.fade. 800 milliseconds is the duration, 80% of a second. And then zeros for all the RGB values. I'm just going to set them together like that so you know that block there is, or that little set of 3 numbers is the RGB. We don't want to replay the fade out. And then we're going to have callback here with camera progress. And like so, okay. Then within this, we want to check if the fade is more than 90%. Progress is greater than 0.9. If it is, start the next scene. Okay. So if the transition is 90% complete, then we want to say this scene start and then go to the next level. So this is going to be this, which is referring to the scene. The this keyword is in this sense is always referring to the scene that we're in. So we haven't changed the context of that. Next level, and the scene contains the levels. And then next level, what we saw with this is an array, right? So it has, within the class of level, it has an array that's set to, or I guess an object that's set to these 3 levels. Wait a second. Where's the level key? Next level, this is going to be this dot level key. And where is this? Where is level key? So level key is up there. It equals key, right? So whatever we're putting into the constructor, it equals key. So we need to do some digging here. Yeah, so then down in the tertiary classes, right, the subclasses of the level subclass, or of the level class, we have the super putting in each of the level keys to the parent constructor, which is up here. And so within this is going to be the level key, which is also the same value there. So then when we see this down where we're adding it, in this array, it's basically saying that, okay, so this level, this next level is accessing that object. with the array value of the level key that you have. Okay, I think that's all we need. And now, if we keep going, can we play this? Can we go all the way to the end, or are we going to add a bonfire? I think we have to add a bonfire in a little bit. Oh, it's right there. Haha, woohoo! Of course, if he stays at the bonfire, then we'll keep flashing because it doesn't switch to the next level. Either because, I mean, we put in everything correctly, it checked us on that, but I think it's because there's not, like, the levels are not being initiated to go to the next one. Not sure what's happening. They'll probably explain it in the next section. All right, maybe not. Parallax scrolling. We're going to create the illusion of depth in our frozen tundra world using something called a parallax effect. Parallax motion refers to an observable real-world phenomenon. That things closer to us move faster than things further away from us. It's the illusion of that, right? A full moon or a faraway mountain may not appear to move much at all as you drive down a highway on a clear night, but it's simply so far away that the movement is occurring very slowly. And because the objects are so large, right? You know, if a mountain takes up miles of space and you're driving, you know, only a couple miles in your car, then you won't see it move much. And you'll see it move in comparison as a proportion of how far you're moving in the car. By comparison, a hedge of trees against the road or a neon light for a roadside shop will whiz by. Yeah, so in order to simulate this motion, we can create 3 different background layers of different sizes. Why do they need to be different sizes? Since we'll be scrolling some of our nearer layers very fast and some of our farther layers very slow, we will need our nearer layers to be longer, or else they will scroll off screen. Okay, we're going to put in some detail in our background here. So find the create parallax backgrounds method of our level. Inside, we're going to create a smooth parallax effect, but first we need to add the 3 stacked backgrounds. They are game state background 1, 2, and 3. Okay, let's see where the parallax backgrounds function is. And also, before we do that, I want to check to see if their bonfire is working. So that we get to the end of the screen, we'll see that it actually resets. Hey, it reset, and it went to the next level. So this is level 3. Now, what was the difference between this code and the last code? Because they must have added something that we did not have. If progress is greater than 0.9, you stop this level key and you start the next one. Oh, I see. I don't think we had this part. We had to stop. That's what they didn't tell us, I think. We had to stop this level key and then start the next one. Did we have that? Let me go back. What was the difference between our code? Because this is important. This is like switching the levels over. Yeah, so they just didn't. If we stop the current scene that we're in, they neglected to tell us that this dot level key. Now if we get to the bonfire here, but now it still doesn't switch over. So did we save it? Save it? Try that again. Nope, it still stays on the same level. That is very strange. This restart level key. Yeah, very strange. Okay, let's look at the next one and see if we can unpack this. This is separate from our parallax. We're just looking at the level construction here. So if we go past the animations and scroll down to our level setup, X index, Y index. This camera's main fade, all of those are the same. This scene dot stop, this level key, this scene dot start. Null of this. Restart there, all the level. The supers are all the same, the classes are all the same. I'm not sure what was happening. Something was looping indefinitely. Game state cursors, blah, blah, blah. This was just in the level setup. Progress is greater than 0.9. False. There's one other thing. Let's see. I don't know. I kind of want to just copy what they had over there and then see if it changes here. But it checked off our progress as if it was correct. Oh, if progress is okay. 0.9. 0.9. There we go. Because progress is never going to be above 1. I just forgot the decimal point there. Let's try that again. Try that again, see if this works. Haha! Now we get to the second level. Sweet. Okay. We'll go ahead and add in our parallax backgrounds, or our layers for the parallax. Okay, so we need to find that function here, which is underneath our animations, like so. Create parallax backgrounds. So we're going to create a smooth parallax effect, but first we need to add the stacked backgrounds. So we need to add these images to our scene at 0, 0. So this dot create, or is it just, I think it's just this image add, right? This image add, and then this is going to be game state .bg1. I'm going to go ahead and copy that because those are going to be, we're going to have 3 lines of this just at 0, 0, but we need to have the coordinates be before our image key. I think that's all we need. This image add, and then just change these two backgrounds to be 2 and 3 and have 3 lines of that. Let's see if that works. I don't think I have the command right. What is the command for? It's this add image. It's not this image add. Yeah, that's what's wrong. So if we scroll back down to this, yeah, it's this add image. And then we'll go ahead and switch that for the other 2 as well. Okay, and then change these to 2 and 3. Okay, but where is this correct though? Are we, no, we only have it 3 times, so maybe that's not. Do we need to say game state.add image? No, because it's adding it to the scene. This .load.image of these. This .add.image. I think there's just something that I am missing. Game state.background 2. Oh, hold on a second. We don't need to write game state because they're loaded in as images that are just set to the backgrounds. So we don't need the game state word. Excuse me. Game state does not need to be included. Okay, so we have them in there, but they need to populate at 0, 0. And then we need to assign these to the game state properties. So yeah, this was, yeah, it's obvious now, but this is confusing because it's saying that the backgrounds are, meaning like their names are these 3. But we're not we're not adding those as in like those are the image keys. These are the variables we're assigning them to, or rather the properties we're assigning them to. So game state dot honestly, like if they just said, okay, go ahead and put in the backgrounds with the background keys without any of this information, I probably would have done it. But I was just trying to follow exactly what they were saying, and then anyway, got confused. So GameState.bg1 is going to equal this.image, and then it will draw it out correctly, right? So we're going to have that with GameState.background2. And GameState.background3. Voila, there we go. But that doesn't look quite right. We need to reset the origin for those by calling set origin on each of them. Okay. Now, we honestly didn't need to store them anywhere. We didn't need to store them in the properties. But it's good that we do, because then we can move them later or set like the camera, like the camera proportion? I don't know if you actually need to set it for parallax. You just need to design it to be used for parallax. But now we're going to reset the origin for each of those to 0, 0. So at the string of this is setting it to be 0, 0, so the origin point of the image. But the origin point of the image is seen as the middle point, the center of the image. So we're only seeing a quarter of it here, right? Or like drawn from the center outward, where we want to say we want the left corner to be at 0, 0. So we need to set their origin from their center to the left corner, and this is the way we do that, by saying set origin of 0, 0, and the default for the game, or the phaser default for origins set at double zeros, is the top left corner. Okay, so set origin, and then we'll just copy this down for the other two, and then we'll be looking better here. There we go. Sweet. Look at that. Got our mountain in there, but yeah, we do need to add another variable or two for our parallax, right? But we've got our backgrounds loaded in, and now add some parallax so that they can move more realistically. Determining the scroll factor. In order to accomplish this effect, we'll update the scroll factor of each of our background layers. The scroll factor is how fast an object scrolls with respect to our camera. By default, all game objects have a scroll factor of 1, where it scrolls as fast as everything else. A static object that we always want on screen should have a scroll factor of 0. When we can set the scroll factor with the game object method, set scroll factor, but what should we set the scroll factor to? The scroll factor is the rate we want our background to move. There are 3 numbers that we use to determine it: the width of the game, the width of the background, and the width of the window itself. How do we determine the rate that a smaller background should move so that the entire background only shifts as fast as the player moves across the level? With a formula. Here we go. Constant window width, config width, constant game width. So this out the variables for the largest background, 2000, okay. So the largest background width is 2000 pixels, and then the window width is just whatever you set in the config, which I think is 500. Okay, it's 500 at the moment. I don't know where this is going to be. Is it going to be after the backgrounds are created? Or no, it's within the function that creates the background. So then it sets the scroll factor for each background. Okay, and then they have a third one saying some background width equals GameState.someBackground.getBounds.width. Okay, cool. They're just setting that up to be a catcher for things. constant some background scroll factor equals some background width, window width, minus window width, divided by game width minus window width. And then you run that function within the scroll factor on each background, right? Okay, so what that's doing is saying that so when we run this through this function or this variable through the set scroll factor method, it's taking that and then saying the sum background width, which is set to the bounds of whatever background you've set here, right? Whatever the background you're calling it on, it's finding the bounds of that. That's the sum background width, subtracted by 500 pixels, which is our current window width. Then it's taking that value and say it's larger, right? So you still have some remainder left over. Say your game width is the largest background that you have, so it's 2000. So 2000. That's the second part of the equation. Let's see if we can finish thinking about the first part first. So we're saying whatever the background width is, it is 2000. Say that you are accessing that. So it's 2000. That's the largest one. Minus the window width, so you have 1500 left. Divided by the game width, which is the largest background, subtracted by the window width, which is 1500. So what do you get? You get 1500 divided by 1500. It equals 1, right? And it's kind of strange because if we're setting the scroll factor to be 1, then it will move just as fast as everything else. So that's moving as fast as the camera is moving. That's weird. It's weird. Yeah, because that would just equal 1, right? That's not going to equal 0. Well, it would equal 0 if you had a window width the same as your background width. So it would be 500 pixels, and then there would be 500 pixels on screen. So that would be static. But if this equals 0, what that should mean, like thinking about it in terms of the camera, it should be only on the first, like the first part of the screen, and then as soon as you cross the line, it won't be there anymore because it's only 500 pixels wide. That's set to 0, so then it never moves. Oh, yeah, because you don't have any more information there. So it's like, if the trees were only 500 pixels wide, if that image of the trees was only that wide, then they would stay on screen the whole time because you don't have any other information to show. Yeah, so it's setting it proportional to the window width, so you always have all of your backgrounds on screen. If it's a larger background, then you'll see more of it as you continue on. And then the speed of that is determined by the proportion of this. However, with this formula set up, I think the highest value you would get is a 1, which is just as fast as everything else. Yeah. But I think, so in this case, our foreground images are longer than our background images. So thinking of it that way, it makes more sense where the front image would always be moving. You would always be seeing more of that. But say that the mountain is only 500 pixels wide, right? It's only as wide, or like say 1,000 pixels wide. You would still see the mountain for the whole time, but it's going to be appearing like it's moving more slowly. But basically with this formula, you're saying keep the image on the screen the whole time, and depending on its width, have it move more slowly. Since we have more of our foreground image to show, that's going to scroll faster. That's going to be at 1. And since we have less of our mountain to show, that's going to be at 0 or close to 0, so it won't move much at all. That makes more sense. I was thinking of it literally the opposite way, where I'm like, well, the mountain is bigger, so why don't we have a larger number for that? And then, but I was like, but then that would move faster, like everything else. But anyway, we want the ones in the background to be at 0, because we have less of them to show. Where we can see more of them in one snapshot, right? Okay, so at the end of create parallax background, set the scroll factor for game state background 1 and 2 with a given formula. Okay. Do we have to... Okay, so they've set up the variables for us. They've set up the widths, which is just get bounds.width. That's very helpful to have. That tells you two things. One, why it was so important to store these somewhere and not just populate them, because we're actually changing their values. We're not changing their values, we're accessing their values and then having the camera behave differently based off of that. So then get bounds calls, it's a method call on these sprites, or not the sprites, but the images. It's a method call on the images to get a certain dimension of those. And we've got those stored in variables here. Then we have the window width and the game width, which is this parse float. Parse float, I have no clue what that does. Game state.background3 get bounds width, game state width equals game width. So that must be the largest background, eh? Okay. I don't know why they had to use this and they couldn't just use the bounds. Parse float. I don't know what that means. Anyway, set the scroll factor for those 3. So we want to say constant scroll factor and this is going to be equal to, do we need to set up a variable for that too? I think we need one more variable because we have the game width, we have the window width, we need the sum background width. Or no, they're just using that as an example. We need to input the background 1 width, background 2 width, etc. So let's copy those in. That'll give us the bounds for that. This is going to be, let's see, subtract window width and then outside of the parentheses for this, this operation needs to be within parentheses. Outside of this, we need to divide by game width, and this is like underscore they put, underscore width, minus the window underscore width. Okay, I think that's all we need for the first one. But the scroll factor for that, it's going to be scroll factor 1, scroll factor 2, scroll factor 3. Is there a way? And of course there's a way to do it where you don't need to write all of these out separately, where you can just have like a variable to store which one you're referencing. So a function that accepts an argument of some backgrounds.scroll factor, and then the scroll factor argument would just be like these, right? That would be more efficient. We're just going to do it this way because we've already set it up with that first scroll factor. We're going to create 2 more. Or just 1 more because they just wanted the first 2. This is going to be background 2 with, let's see if it accepts that. scroll factor for the background images. I mean, oh, I actually need to call that too, right? Some backgrounds that scroll factor. Yeah, that's the other thing, because this gets kind of bloated kind of quickly, huh? All right, just for good practice, I'm going to create a function to do this for us. So yeah, just like, or we can create a variable with a function, yeah, like constant. So constant scroll factor factor. This is going to have an argument of background. I'm just going to call it BG, and this is just going to be BG. Within this, or this is going to be contained within braces. And then let's bring this down to the next line here. Okay, and bring that down as well. So scroll factor, the function here is going to equal this. There we go. I think you can do it that way. Scroll factor background, then the background is subtracted by the window width, game width, subtracted by window width. Okay. Now we can call this function on our next line here. So we need to say scroll factor for background 1 width, and then background 2 width. Is that how that works? Hold on. I don't think I'm thinking of this correctly. I don't think my syntax is right for the function, but hold on. We'll get to that step of a second. So scroll factor background 1 width, then do the second one here. 2. Okay, I think this is off. I think it needs to be equals that, but then you're not declaring a function, so you just, yeah, it just needs to be like that, right? No. And now it's completely broken. Did I forget how to do I'm just making a function declaration. We don't need to set it as a variable, we just need it as a function. No? Not that either? But why? But why? Scroll factor. Where does this go? Create parallax, okay. These are outside of that function. Should accept the argument of background and then change it there. Have we done everything else correctly? So game width minus window width. Those two are fine. That syntax is fine. Have the dividing operator there. Background. Oh, but we actually, so we're feeding this, okay, I'm thinking of a step behind this. This already has a method set for us. We don't need to set up a method. We just need to set up a variable to put into the method. So is there a way to do this without having to call that 2 different times? Where you can just call it, or well, we'll call it twice, but I don't want to like set up 2 different variables for that. You know what I mean? So like, maybe, because what we had before was fine. We just said constant scroll factor. Get rid of the function notation. Don't need that. And then just made this a variable and said constant scroll factor equals some background minus width. And then what we're doing here is game state Yeah, I guess it's not necessary because you're just calling it on whatever background you have. So there's not really a way to make that more efficient. You just call it twice here. So game state background one with set scroll factor. Set scroll factor to background one width. And this will be background two width. Is that game state dot background two without the width? Background one without the width? Okay, well we have the backgrounds, but not Cody anymore. He disappeared. Yeah, I think we need another variable. Or two more variables. How do you do this? Okay, let's work backwards here. So we're calling the set scroll factor method. Got that set up here. That takes an argument of not the background width, right? We don't even need the game state call here, because we can just say call it from the variable itself, which is already set up to be the width of that property, that game state property. So underscore width, set scroll factor, background one width, background two width, right? These aren't correct though, because these are going to be set to the variable that we want to run the formula in. So scroll factor Okay, now that's a little bit better. That's closer to what they had in the example. So scroll factor is acting as the sum background scroll factor, right? That is a variable set to the formula. The formula has another variable in it that says sum background width. Yeah, we're just going to need three of these. So scroll factor 1, and then scroll factor 2. I don't really see another way to do this, so we're just going to need two of these backgrounds. That needs to be changed to background 1 underscore width. Background 2 underscore width. Scroll factor 2 and scroll factor 1. Anyway, the formula for this, the formulas are the same. The widths are different. There is definitely a way to make that more concise where you only have to set one variable, but it escapes me at the moment. So let me try this and see if it works. It still does not work, probably because they do have the more efficient one already coded and about to show us, eh? Game width minus window width, scroll factor, BG width, window width. Width. Get bounds of width. I've got to take a look at the hint, because the only way to do this, if you could reference multiple widths here. Which is what they're doing with that, right? So you do need to call the background still and not have it be the width like that. So maybe that is my error. Just take that out. Take the width out there. Put the game state back in. Game state out background 2. I don't understand it. really don't understand it, because that's what they're doing. That's exactly what they're doing. So take this away. Take the second one away. Just show the first one. This is set scroll factor. Scroll factor 1. Window width. Oh, brother. That's what's going on. Hold on. This variable is not spelled correctly because they don't have it the same as the example. So width is, it's underscore. It's window underscore width. That's why. Okay. So let's see if that works. There definitely is parallax. There's some jitter, but there's definitely parallax. But for some reason, CodeCademy is not happy. What did they want instead? Using the given formula. Okay, so let's try now that we know what was the issue, let's try it the other way then. Let's give it a generic background. Let's try to solve this within one variable. Give it a generic background. Say whatever we put into here, we want that background to be one of these, right? And then ignore this as well. We will have to call it twice, yeah? So set factor like this, scroll factor of nothing, there. So we call the scroll factor in background 1, scroll factor. This looks at this and says that, okay, so this is going to take the background, which is some value. How do we get it to, we have to make it a function, yeah? We have to make the argument of this function a function for it to do that. I don't know if that's what they did. I'm going to go ahead and check it out. Oh, they just did it. They show us how to do it this way, and then they're like, oh yeah, whatever, don't do that. Just have it be all within the same method. Just put in the variables, just change that, and then everything else is the same. Okay, here I'm thinking like, oh yeah, they want to make it more functional, so we need to find a more efficient way to do this. We don't need to find a more efficient way to do this. We need to find just a more, you know, overt way of doing it, of just calling the variable from within the method. That's it. That's all they wanted. And yeah, that is more concise. It's not as elegant because you have to run that like as many times as you have background images, so it's still not like a good way to solve that if you have like hundreds of background images. You have to type out that every time. But nonetheless, that's what they have. So we will just do that. We'll just do that. Yeah. So can we just copy? I don't think we can copy the things in the blocks there. So we're just going to copy this over. I think we just need, yeah, just this. But again, like the solution that we had was fine. Like with the 2 scroll factors, that worked. We have parallax. It's just it's not what the module wanted. The module wants something else. CodeCademy wants us to call it twice, but then not set up variables for it like they showed us how to do up there. Not salty at all. Okay, so just change this to be that formula. Did I actually copy it, or do I need to go back and copy it again? Let's copy that down. Let me copy this over there. Okay. It's like you show me what to do, and then you do something different where I was trying to copy what you were doing, and still it doesn't like it. What don't you like about this? Set scroll BG1 set scroll factor. You need this to be like spaced out the same way too. BG1 like this. Are you happy with that? Set scroll factor BG1 with, oh, I need 2 on here. BG2 width. Okay. Alright. There we go. Now we made it happy. Made CodeCademy happy. Look at that beautiful parallax. Yeah, beautiful parallax. Look at that. See the mountain moving? It's jittery. But the mountain's moving slowly. The trees are moving a little bit faster. and the snow is moving the fastest. Sweet. Again, there are multiple ways to accomplish that. If one of you guys found out a way to make a function to fit within that other function, I'd be happy to see it. I think we definitely could. It's definitely possible. All right, let's play second level here. Aha. Cool. Looking better. Changing the weather. If a long journey goes on for several days, how do we communicate that length to the folks playing our game? We're going to use a few strategies to add in concepts of ambience, lighting, time of day, and weather to our game to make these same assets feel like the world they're part of turns and changes like our own. Breath of the Wild, here we come. The sky's color is the easiest thing for us to change by changing the background color of the game. Since we actually want to update the color of the sky multiple times within our single game, we can make a new background. A rectangle with the same dimensions as our canvas. We will be able to update the color of our new background with the appropriate color of the sky. Alright, so let's create the background that's going to become the sky now. So before making any of the other backgrounds, we want to make GameState.backgroundColor a game object rectangle so that we can update it to different colors. So this is before we add any other background, before making any of those in the create. Essentially, you can put this just right here, right below the GameState.active. This.add.rectangle, and it'll have the following arguments of 0, 0x, 0y, config width, config.height, and 0x, 00, AAFF. This will all be assigned to GameState.bg color. What did I spell wrong? GameState.bg color. Oh, sorry. There's one more thing on there. Call set origin. Set origin of 0, 0. Right, because it's only showing us a quarter of what it is. There you go. And we got a blue sky in the background. Look at that. Look at that. Still have our parallax working. Beautiful. So now that we've created, they've created a set weather method to help update the background and add any other changes to our levels that we might need. Let's go ahead and find that. Set weather. There's our parallax. Set weather, level setup, update, here it is. It's a helper function. Set weather with morning, afternoon, twilight, and night with 4 different colors. Okay, after checking if weather exists, set the game state background fill color equal to background color. Inside of set weather. Okay, so we're seeing if the weather exists, which it does now since we created the game object slot for it. So let background color equal weathers and the array of weather. So the variable they created inside of their function is an array of objects called weathers, and then what we're passing through that is the argument of a singular weather, which is also the same as here. All right, so we're going to update it to background color. So game state .bg color .fill color equals bg color. All right, sweet. In order for this to take effect, we need to add weather information to our levels. Find where we define level 1, and inside the constructor set this weather to afternoon. Okay. This.weather So each level needs to know what time of day it is to afternoon. Ta-da! For level 2, let's set it to twilight. Twilight. And now, if we complete the first level, ta-da, get to the bonfire, see our lovely transition, move to the next one, we can see that our background has changed. It's a little bit darker. And then if we switch to the third level, it's not set to anything in particular, so it just defaults to what we said in the create method, which is the blue sky there. Okay, changing the lighting. Different light colors things differently. So it'll be a stronger effect if we color our world for each time of day. Ooh, that's cool. Look at all the things you can do with just JavaScript and the phaser framework, right? In order to convey this effect, we are going to use the setTint method on each of our game objects. SetTint performs a color multiplication effect that changes each pixel in your image consistently, in a way similar to having colored light cast on it. It's a lot like looking at the same thing through a pair of sunglasses. When we do this, we can contrast the effect of a strong overhead sun during the afternoon with, say, a lavender light present in the early morning. At night, we can just make everything a little bit darker. All right, so let's find our setWeather function past the update. And underneath the setting it to background color, where did the if statement go? Oh, they changed that. They changed it. I love this. They're like, they show us how to do something, and then you go to the next exercise, and then what you just did is gone, and something else is there that's more functional that they didn't teach you about. Like let color, background color, setting like an object variable thing equal the array of weather, and then setting the fill color to background color. Okay, sure. All right, so in setWeather, we've given each time of day a tint color. Let's apply that tint to all of our game objects to adjust the lighting for that time of day. First call setTint on GameState.background1 and give setTint the argument of color. All right, GameState dot background1 dot setTint of color. And what is that doing, you might ask? We shall see. Now do the same for GameState.background. They're not explaining why you just put in color. Set weather for what, though? Are they setting multiple... What is this doing? Is it setting multiple variables at once? So it's setting the color property to be the background color currently. Okay, so we have GameState background. They want us to duplicate this for the second and third. So we'll create 3 lines here, change this to background 2, and change this to 3. And that's just set, the color variable is just set internally by this, I guess, by that variable. Setting it to the current background color, and then we'll change this individually. Okay, that's not everything in our game though, so let's update Cody's tint too. Set tint on GameState.player. Oh, I see. So yeah, it's just setting up like a generic, whatever the tint may be, setting that up. So GameState.player.setTint, and then whatever the tint color is. Where that's set, I'm not sure yet. Lastly, let's do the platforms. To iterate over the platforms with a for loop over GameState.platforms.getChildren and set the tint for each platform. All right, a little more complex, but easy enough. Say for let I equal 1. Separate these in the for loop, the arguments here by a semicolon, not a comma. Let I equal 1. Let so for when I is less than game state dot platforms, I guess equal to, right? We want to say equal to get children I increments. I think we want to say this is equal to, right? So that's when it will stop, or if it's greater than that. I guess less than that works fine. Just once it's equal to it, it won't iterate again. Okay, and then set the tint for each platform. So, wait. So then we need to call the index of I on that. Yeah. Okay. So platforms, call the index of I on the children on this array. So get children within this array. Do we put I? Just the index of that. I think that pulls out a specific index, yeah. So that index, whatever's at that index, and then set tint. So logic is sound. Let's see if the syntax is. Hey, look at that! Look at that. Okay, cool. That actually worked. So yeah, I here is, since the get children references the whole array, if you put something within those parentheses, then it's saying look at the index that I is, and now all the platforms should be tinted to the proper colors. Let's see when we play the game. If we progress through the levels, it will actually change the tint. So we get to the first bonfire. Look at that. Nighttime, or it's twilight for Cody. Are the platforms actually being tinted though? I don't think so. Oh yeah, they're not. They're definitely not being tinted. It's really funny because they're like, "Oh yeah, this is how you do it. Good job, you did it," and then that it didn't work. Yeah, it's morning time. Look at that. Well, everything else is being tinted just fine. Oh, Cody. He barely, that was a perfect jump right there. He barely made that jump. Ah. Oh no. See if they give us like the longest jump possible. Wait, there's still another level? Wow. Or did it just not go to another one? Yeah, It's just playing the same one over and over again? Because there's no, at the top here, it doesn't go from like level 4 to level 1. And there's no end screen either. But anyway, cool. So the tint is working for the most part, except for the platforms. Let's see, since they have a habit of doing this, let's see what the next module or the next exercise is, and then take a look at the code in there to see how that actually works. So in our helper function here, platform set tint. Oh, so you don't need to do it that way. It saw that we were trying to access it, but it didn't actually work. So all you needed to do. Oh, okay. That is very different actually. So they didn't use an iterator with a variable like a variable that's incrementing. Instead, they just said that let platform. This is the smarter way to do it. Let platform of GameState.platforms.getChildren, meaning that for each index of the array, for each element within the array, this is acting as a for each method. You could also do a for each method easily. by just accessing this and saying for each. In fact, I kind of want to do that as a proof of concept. Let's go back and see if this works. And yeah, so instead of instead of this, which even though we passed the test, but it did not work. It's not functional. So instead of that, and instead of the for loop here, or any, yeah, literally like any of this, we don't need that. We just need to add a for each at the end. We're not writing HTML code. There you go. Okay. Okay. Now, for each. This is just going to be platform, right? And I think, so this needs another set of parentheses for each platform. Is that how you do? I always forget the for each because it's not the same. It's not the same syntax as everything else, eh? It's just platform. Like you don't even need the parentheses here unless you have multiple parameters. I think it's just platform. I'm gonna go check it on the MDN, right? The documentation on JavaScript. See what the for each is all about. I always forget. Always forget. Okay, so for each. Boom. Element. So you do have an arrow function in there, but you don't have the brackets. Okay. So it's just platform. Like so. You don't have the brackets. So our function within this is going to be platform. So each element of that array. Dot set tint and then color. Yeah, like that. All right. And nothing happens. Good job. Yeah. Okay. Well, that didn't work. Did not work. For each get children. Does it work if you just say platforms because platforms already has an array in it? Oh boy. Let's see. Let's see. It just reloaded. Let me see here. Okay. Nope. That doesn't work. How do you get the children? I guess you have to say for. Say for let something. I don't know. Yeah, maybe it's not possible with a for each. Even though this is accessing an array, you can't get it. How do you get the array? I don't know. Anyway, so maybe the for each method doesn't work on that. Maybe it's only, you can only create a loop for it. Like they did here. So with a loop, with for loop in, they say let platforms, or platform, which this is essentially reverse of the for each, right? Instead of tagging it onto the end, you're just making it a for loop and saying for let. And that's basically acting as a for each method. So for let the element of game state dot platforms dot get children. So this array here, for each element of that array, set the tint color, and now as we play it, and if we can progress to the next level, we will see that everything has changed. All of the colors are tinted, and now it feels like we are in a snowy environment in a twilight scene, wandering through the wilderness in the dead of night. And then it's morning. Okay, so lastly, so all of our tints are working. And then we'll go ahead and reset this. So lastly, we are going to make it snow. Where does all of the snow in our game world come from? We assume it falls from the sky, but how? In order to enhance the realism of our game, we want the snow to fall as the player crosses through the tundra. In order to do that, we will need to use the particle emitter. There's a particle emitter in this? Look at this. who needs Blender? A particle emitter creates a pool of particles. A particle is a small repeated sprite. A pool is a collection of these particles collected for reuse. Instead of constantly dropping new snowflakes, we will move the snowflakes that have dropped already to the top of the screen and drop them down again. We can add our particle emitter in create like so. Alright, so particle emitter, this add particles with marble. Create the emitter using all of these properties. This creates a particle emitter that uses a marble asset. Okay, so there's a preloaded asset here. They're using that as a particle. It creates the particles at the top of the screen and pushes them down the screen. It creates these marbles at x coordinates between 0 and 200 and gives them the variable speeds as they fall down the screen. Lifespan of 2 seconds, 2000 milliseconds. And then it has acceleration due to gravity as well. So particles implicitly have physics added to them, I guess. Quantity of 10, and then blend mode of add. So they're not going to be completely opaque. They're going to be slightly transparent, just like snow. That's cool. Quantity of 10 particles at a time. So 10 particles to spawn at a time. And it spawns them from somewhere between 0 and 200, which is like the left portion of the screen, the top of the screen. With a y of 0. Okay, cool. What was our... Yeah, so the width is 500. So you might need to adjust that to be 500 so the snow is falling from everywhere and not just like on the left side of the screen. But we'll see. Inside create snow method, we're going to add in our particle effects first. So where is the create snow method? Create snow. Snow, 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 snow. After the weather, perhaps? Background color, emitter, level 1. I think it's just within create then, huh? This weather, level setup. Let's see, create platform, game state. Yeah, maybe it's down there. Create snow method. Is it down here? Weathers. I see a GameState.emitter. Is there a create snow? Oh, it's right there. Oh, it's at the very top. Okay. The create snow method. This is before the constructor. Hold on, what's going on here? Why is that before the constructor? Constructor always goes first. The super always has to go first. Anyway, don't question it. Okay, so first off, I created the game state dot particles and add them in with this add particles. Okay. So this equals, yeah, this dot add dot particles of snowflake. Okay, just like that. All right, now create the emitter as GameState.emitter by calling GameState.particles.emitter. Okay, GameState.particles dot create emitter. Emitter like so. With the following object to start making it snow. All right, so X is going to have a value of an object. A minimum of 0, ranging to a maximum of config.width. Config.width. Not config, config.width times 2. So it'll be 1,000, yeah, so 1,000 pixels over, which is like, it's calculating for what's on screen plus like 250 in either direction, I guess, if you're, because the config window is always going to be the same. Like we're always seeing the config window and it's just saying like 0 and then times 1,000, meaning that if we go forward, like if we move Cody past our current frame and the camera moves, that the snow will still be there and we won't ever like outrun the snow. So okay, so that's X, then Y. Y is -5. So it'll start a little bit above the screen so we don't actually see them popping in, just like with the bugs. We first put them at 0, saw them popping in, and then eventually put Y to a negative value so they could have a little bit momentum before just like appearing at the top of the screen. All right, then the lifespan, that's going to equal 2000. 2000. Then speed of X, this is going to be an object as well, with a minimum of -5 and a maximum of -200. So they're going to be moving a little bit to the left. That's going to be cool because it's going to look like Cody's getting hit in the face with snow. Like there's a little bit of wind, right? And then speed Y is going to also be the same syntax here. So we're going to have an object underneath the speed of Y and have this be minimum of 200 and maximum of 400. So it's going to fall, and then according to gravity, it's going to go a little bit faster. As it falls, it'll increase speed, it'll accelerate. But it will reach a certain acceleration, it will reach the snow's terminal velocity, and it will terminate its velocity. All right, scale. We're going to set that to an object as well. This is going to have a start of 0.6 and then an end of 0. So the snowflakes are going to be larger, and then they're going to reduce in size as they fall to the ground. That's cool too. And blend mode is going to be add. So nice that you can add blend modes in here. Blend mode is going to be add. There you go. Otherwise, you'd have to like design it like that, where you put the blend mode on it before you export it as a PNG, and then you bring it in like that. Also possible, not too difficult, but it's very nice that they have them built into JavaScript. And let us see, we got it wrong. Okay, how did we get it wrong? Hey, we got the snow though. Look at this. Look at that, and it's also sort of randomized too. Blend mode of add. So what did we miss here? Let's see. Let's go ahead and like, just for clarity's sake, let's type it out exactly as they had it, like this. I don't think it matters. I mean, it literally doesn't, however the spaces are, but all right, game state.particles.create emitter. Create the game state.emitter by calling the game state.particles.create emitter. Thank you for the follow. Hello, how's it going? Welcome, welcome. Let's see here. Particles.create emitter. Snowflake. We are currently making a little platformer. This is with the game objects and the... Oh, the snow disappeared there. This is with all of the preloaded assets from CodeCademy. We're making a little platformer. And so far we've got it to where we have different levels and different times of day for each level and transitions. Yeah, it's a web game, or at least it can be. It's not on the web right now, but it can be. And yeah, so this course is mainly about building browser-based games using JavaScript and Phaser. I think is our lose condition still working? Yeah, okay, cool. So that's still working, and then you restart the current level. Cool. Okay, we'll go ahead and reset this back to the first level we had. See if we can figure out this snow. Oh, I missed the quantity. We need the quantity in there. And they have 10, just like that. I think that should do it. No, it's still, whoa. Yeah, yeah. You can go ahead if I ever publish one myself, which I'm sure sure I will eventually. But yeah, I don't have anything. I'm currently learning right now. But yeah, once I get there, sure. Okay, with the following object to start making it snow. What else am I missing here? No, I don't have any published games. This is literally my first time learning any type of code. So we got all those right. I did create the particle emitter. Okay. So yeah, the hint on this is like literally what we had, except oh, they want us to store it as a property. Okay. Game state dot emitter equals that. Did that work? Okay, cool. So yeah, they just wanted to store a property of the emitter, so that we can reference it later and make changes. All right, so now we got the snow. We got quite a bit of snow. It's pretty cool, huh? And then it disappears because there's no loop on it. It's just whatever we set to that end y value or the end x value there. So I wonder if they'll have us, because we could make this like times 5, like the config width. Oh yeah. Oh, they're showing us how to fix that in this step. So it scrolls out the screen with the camera. So let's fix that by setting the scroll factor of our emitter by calling GameState.emitter.set scroll factor with 0 as an argument. Okay, so we learned this before. If we call the emitter, and we can just do this outside of here, right? Just do this within the create snow. So right at the bottom here, have GameState.emitter.set scroll factor. Factor with 0 as an argument. And what we saw before with this is that it didn't move. The parallax was non-existent for these ones. So then it's always on screen. Yeah, sweet. So it's actually an illusion where the snow isn't, it's just following you. It's like attached to the camera. That's cool. But since it's randomized and since they disappear as they fall down, then it's all good. It looks like actual snow that doesn't follow you, but that it exists in the entire world. Okay, cool. Okay. Well, thank you. Thank you for the invitation. All right. Well, I guess that was all for the platformer there. Do we have it built? Okay. So they reduced the they reduced the amount of snow, so it's a little more pleasant outside. Sweet. So throughout this lesson, you learned many ways to polish the effects in Phaser games. We created cameras, special camera effects, particle emitters, tinted sprites, parallax scrolling. Cool. What an incredible series of good-looking features our game has now. Yeah, right? Right. We started out with just a blank screen with Cody falling into the void. Now that our game is looking fabulous, let's make a little credit scene together with Cody sledding. So we've added a credit scene after the 4th level featuring Cody sledding away to safety. Use your skills with effects and add in a background. And make sure to put your name in there. Congratulations on an amazing game. Okay, so last challenge here. Where is the credits? Oh, I see. So they added in a credit scene. Let's go ahead and find that. And update. Create stars. This within space. Whether, oh, they created stars for the background too, for the like the night scene. That's cool. Instructor credits. So what does the credits do at the start here? What does it do now? Let's finish this game. Oh, the snow is more intense at night, I guess. kind of cool. So they changed the intensity of that. And then we can see some stars, which they just, as you can see, they just used the snow sprite for those two. That's cool. They're kind of behind the mountain. The parallax is working in reverse because stars definitely wouldn't move that fast, but you know, it's all good. The mountain apparently is somehow in front and behind the stars at the same time. Alright, then it's morning again. Let's see if we can get to the end here. And watch the credits. Da, 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 da. Woohoo! Sledding. Okay, so where is this credits scene? Ah, okay. So preload is all in here. They say to add a background and all of those images. I'm just going to, let's see, maybe add the snow. Stacked a couple times. And then you could put in text, but really I just want to add the background in. So let's go ahead and find out where the snow is created. Cody, what is it called actually? Is it just called campfire background? It's just the background 1, right? Or is it background 3? This dot add image. Yeah, let's go ahead and add background 3. I think it's just 1. I think it's sequential going back. We saw that before because the mountain didn't move. We didn't program that in. So let's see. Let's go back up to here and then just add it in above the animation creation. This dot add dot image. Or no, this dot add dot image. This dot image dot add. This dot load dot image. Yeah, it's the opposite, isn't it? Like I'm thinking of the creation of the sprites, and that's this dot. Yeah, like this dot physics dot create sprite, or dot create, and then you put in your sprite. But this is this add image, and this is just going to be at say, yeah, so say 0, 0 for the first one. This is going to have background 1 in it. And then the only problem is you have to get to the end of the game to see the credits, so we're going to change that here and just have it be where level 1 transitions to the credits. So all we have to do is complete level 1, and then we can see our work. Now, okay, so no, it is the other way. I had a feeling that it was. They never explicitly said, but okay, so the background 1 is actually the mountain. We want that to be the snow. So background 3 is going to be the snow. We also need to do a set origin on this. Set origin. Like so, and then we'll go ahead and complete this. We could just have it start from credits as well. Just start at credits and then refresh. But then it kind of breaks because that's not the super, that's not the proper super. We need to set it elsewhere. But we'll just keep it like this. Doesn't take too long. Also shows us that our transition is working to that scene properly. So level, how does the level create platforms, blah, blah, blah. How does the level pop in? Like from the start. Is it just the order in which it appears in the scene config? I think so. Yeah. Okay, so let's move the credits up. Let's get rid of that. And then put it at the beginning so we can just see that as we're working on it. There we go. Okay, so the object is not appearing. Set origin of 0, 0. And it doesn't like that for some reason. Background 3? Background 2? What? Background 1. Origin. The set origin method is not behaving. Don't know. I don't know, maybe because it didn't transition and it wasn't able to... Oh, because the images are not preloaded, right? Images aren't preloaded into there. So we need to just grab them from up here. That's the benefit of having it loaded in like this, is that when the credits run, it'll automatically have everything here. Of course, if we set the credits to swap with level 1, then we wouldn't see Cody. We would just see the background. So we're just going to copy all these images down into our preload for the credits scene. Yeah, like so, and then get rid of that one. Place there. And now if we load it in, should have the mountain over Cody's face. There's some snow. And then we need to set the origin to 0, 0. There we go. And then like set scale so that it's a little bit taller. Set scale of like, I don't know, like 1.1. But then the origin would need to change to be negative 50. Whoop, not that. 1. Whoa, what? What's going on with that? 0. Okay. Can we change this value? I'm not sure what these values actually are. I thought they were just X and Y, but maybe not. That's just gone. Let's try 10. Let's try, is it just between 0 and 1 that these are set? I bet it is. It's like between, so 0.5? Yeah, it's just between 0 and 1. So we don't want that. We want that to set to 0. This one is going to be 0.5. Aha. So 0.1. And then scale to 0.3. And then move this up a little bit more, just kind of adjusting manually. It lets you appreciate Photoshop, where you can just like move it around just by clicking. There you go. He's pretty much on it. Yeah, pretty much on it. You can set like the angle a little bit differently, but he's sledding down the hill. Maybe move him over just a tad. So move this to like negative 0.1. Not negative 0.1, but just 0.1 or 0.9. 0.9. But that's the other way. So we need this to be 0.1. Aha. Maybe 0.05? Almost. 0.01? Pretty close. 0.001? No, he's just going to start there, because that's like the closest to 0 that you can get with that thing. Unless you like... You put it to a negative value, so like negative 0.01. Yeah, there you go. Now he's actually more on the surface of it. I could just move Cody too, right? So just undo that last one, set it back to 0, and then move Cody down or over back here somewhere. So 2 config height divided by 2. That's interesting. Config height divided by 2. So he's just put in the exact center of the screen. Let's just move him to be... Oh, I don't need to change the Y value. I just need to change the X value. So let's just change this to like 110. 110. Yeah, he's like in the snow now. 150. That's a little better. That's a little better. That would be 180. Now he's sledding along. Maybe lift him up just a little bit. Divide by 1.9. Oh, other way. Other way. Because that's making it a larger value. So 2.1. Now he's floating above. 2.05. Aha. Whatever. I don't mind it at 2. He's going along like woohoo. From this point, you could add in like get out and like get really fancy and use everything that we just learned. Add in a camera effect. Add in how Cody is sliding like along, like you create a collider between him and the snow, and then just set his x velocity to a certain value so that he actually like moves along it, so that it looks like he's sliding along the snow. That would be pretty cool. But yeah, everything that I just mentioned, we've learned, we just used, and this is then the credits scene. You can put in some text here like "You win, congratulations." And now that we have this, when we transition back out, we'll go ahead and set the game back to what it was, where to start with it doesn't go to credits, but it goes to the different levels. So level 2, let's set this back to, the way we did that was just move the credits from the scene, from the beginning of the scene in the config game object to the end. There we go. Now we're back to level 1. We'll play through it as a victory lap. Congratulations. Good work, everyone. If you watched along, you have now successfully made your own platformer, your own side-scroller. Wahoo! Wahoo! And we've learned how to create enemy logic with like the set colliders, set overlaps, different animations for those, shown how to like shoot pellets out from bugs. You know, let's fix that parallax up there, shall we? Fix the stars parallax. Star visible set to true. Let's see. Where do they have their stars created? Here we go. Create stars. Well, it's not within that then. It's within the parallax, right? So we need to find the... Yeah, parallax backgrounds right here. Did they set up the... Oh. Well, they didn't... Yeah, because they're populating the stars like they are with a particle, yeah. Function get star points. Constant color. Oh, I see it. I see. So they just like created a bunch of dots with a certain radius. They like manually created circles without creating circles. I mean, they did create circles, but they did it like this, where it returned a random value and then a radius and then just filled it with white, instead of just like, there's a function for that. You can just create a circle. There's probably some reason they did it that way, but I don't know. And this way, I don't know how to put, like how to add parallax to... There is for some of them. See, look at that. Some of the stars move, but other ones don't. That's interesting. That is very interesting. Radius, color. Color, star. Star set visible to false. Weird. Yeah, I don't know how they gave it parallax. Constant star, this adds circle. Oh, scroll factor. So you do set a scroll factor to them. But they set them randomly. So let's not set that randomly. Let's set scroll factor to like, what do we want? We want pretty much 0. Like the stars aren't going to move much at all. So let's get back to that level and see that. I think the mountain moves a little bit, so we'll be able to see the stars not move behind it. Let's see here. There we go. That's much better. Yeah, that's more realistic. Now the stars are the things that are the furthest. They're the farthest away, so we do not see any movement in them whatsoever. Cool. Well, let's finish out the game then. Cody walked all through the night, made it through morning, made it across the tundra, and now he's sledding. Woohoo! Go ahead and give him a a mountain background, right? Sled. Have that behind him. Is not add image, this is background 1. And quick way to check this is just switch the credits around. Change it from here to here. Whoops. Not like that though. Not like that, like this. Hey, there you go. He's like on the mountainside, sledding down. And then have the trees pop in too, huh? Background 2. Ta-da! Cody's gone though. I don't know what happened to Cody. Where'd you go, Cody? Are these like obscuring you? Are you not in the front? Interesting. Yeah, how do you set it to be where player.angle equals 20? Okay, so that's how you change his angle. 180. What is that? Oh, wait, that's the... Weird. Yeah, how do you make it so that the player is in front? Because right now it's behind everything. Unless you do it afterwards, right? So this doesn't come after, this comes before. There you go, yeah, you just do it before. Sweet. And you have Cody sledding along. Wahoo! Cool. And we'll go ahead and finish up this quiz and call it for today. So what are the arguments to this.cameras.main.shake? Let's see, we had duration, intensity, force, callback, and context, yeah. Which of the following functions will fade the camera out? This camera's main.fade. Fade out? Oh, I don't remember. Was it... It was setting the delay and then an RGB value. So you could put it as fade out, I guess, but we didn't see that. I mean, obviously this sounds like it would be, but what we saw was that we just used fade and then had it set to a certain color. Yeah. That's a trick question, but did not trick me this time. What is parallax scrolling? So it's a way to make some images appear larger than other ones, a visual tool involving scrolling different background images faster or slower, creating a distance effect. Yes, indeed. What does the force argument do in the fade and the shake? It restarts the effect if it's already happening. Yeah, it restarts it if it is already happening. How do you update a camera's bounds? You do set bounds on the camera. Okay, and then which of the following commands shake the camera? It's the shake, the main shake. Yeah, because you can have multiple cameras. Okay, so that's all for today. But next time, we will learn about this game. We will develop Cody Jump. Whoa! What's going on? Is he? Oh, I see. So he's like constantly bouncing and then you just go up higher. Ah, so we're scrolling it vertically now. Whoa! But right now he accelerates when you hit platforms. So if you oh, you can still bounce on the bottom of the screen and it doesn't scroll backwards. So that's interesting. Whoa! Yeah, if he hits it like right at the apex of his jump, he like gains the force from that. Which doesn't... Yeah, that's cool. They're acting as like springs. Or not even like springs, like something unreal, right? Wahoo! Anyway, this is what we'll be creating. I don't know if there's an end to this. It doesn't look like it. It just looks like it randomly generates forever. That's kind of cool. Creating like a little app game that generates indefinitely, and then it's just based off of high score. That's cool. So we're going to learn about random generation. All right. Well, I hope you enjoyed it. If you watched any of it, thank you. Thank you for tuning in. Thank you for your comments. I will see you next time. Have a good one, everyone. Live long and prosper. Peace to you.